It seems to me that the technology in these boxes is a big reason why HPE spent about $14 billion
screw it.
buying Juniper Networks. HPE to acquire Juniper Networks to accelerate AI-driven innovation. Mist was purchased by Juniper in 2019 for $405 million. There's a good reason why Juniper spent the money buying Mist and extending the capability in the last few years, and why HPE have purchased Juniper now. Now, I'm not always a fan of these, but there's something to be said. If Juniper, for the 4th time in a row, is a leader in the 2024 Gartner Magic Quadrant for enterprise wired and wireless infrastructure. Notice Magic Quadrant. Notice where Juniper is. Notice where HPE is. Aruba Networks. So that's now being combined. So it's going to be interesting to see how this changes in the coming years. But that's enough talking. In this video, I want to show you how to get started with the Mist APs.
Okay, let's get started.
And show you the power of the AI running in the Mist infrastructure. I want to show you how to use Marvis to troubleshoot various issues. Let's see how easy it is to set up a Mist AP and troubleshoot network issues, and also see the capabilities of this product. But before we get started, I want to thank Juniper for sponsoring this video and supporting my channel. Okay, so in this example, I've got 2 Juniper APs. These are AP45s. The unboxing experience isn't really much. I mean, very basic these days. We've got installation guides and technical documentation at supportmist.com. Basically just comes in a bit of plastic, very basic, not really much of an unboxing experience once again. And we've got the wall mounting kit. So that's basically it for the unboxing. But notice a Juniper access point driven by Mist AI. At the back here, we've got a barcode that we can scan to claim the AP. This AP needs to be powered with PoE. Now, Juniper tell me that I don't need a Juniper infrastructure to take advantage of these access points and the Mist AI. So what I've got here is a Unify switch providing PoE and Ethernet connectivity. So I'll be able to use this port Ethernet 0 plus PoE and then power the switch. But notice here we've got a claim code which allows me to claim this access point and register it with the portal. So what I'll do firstly is go to manage.mist.com, and what I'll do here is create an account. So you need an organization set up before you can register your access points. So I'm going to go and register in the EMEA region where I am in the UK. I'm going to put in my name and my surname. I'll put in my email address and I'll specify a password and create an account. We're told that we need to confirm my email and then we'll be able to log in. So I'll validate that on my phone and now I'll be able to log in. So the first thing we need to do is create an organization before we register the access point. So I'll just give this a name. Okay, so we've got our primary site set up. We've got our organization set up. So what I'll do now is use my phone to scan that code and get the access point registered. So I'll go to the Play Store and I'm going to search for Mist AI, and then I'm going to press install to install the app. And there you go. I need to open it. And now I need to put in my email address again. I have to put in my password. The environment I'm going to be using is in the EU. So I'm going to press login. I need to select my organization. I only have one, so I'll select that. The site is going to be the primary site. So going back, I'm going to claim devices to the organization. And what I'll do is allow it to access the QR code. And you can see it says successful. AP was successfully claimed. So I'm going to say done. And then all I'm going to do now is plug in the power to the AP. Hopefully this will power up. You can see it's booting. After a while, it'll hopefully register. Now, before I continue, notice the power requirements for this access point. It requires 802 BT power for full functionality. On 802.3AT PoE, it can dynamically function based on the configuration. To provide full wireless functionality, the AP requests 29.3 watts of power. So you either need to have a switch that provides that amount of power to the access point, or you need to use a PoE injector. So back in the portal, now going to access points, notice we're told that there are no APs found in the site. But if I click on inventory, I can see this access point and I can see that it's unassigned. So I'm going to click more, assign to site. I'm going to assign it to the primary site and click close. It says currently disconnected. If I click on the access point, I can give it a name. Let's call it AP451. Now I'll click Save at the moment because there are a lot of options that can be configured here. And you can see the access point is now connected. So let's go to radio management for site settings. You can see 5 gigahertz radio is enabled, so that's good. If I go back and I'll look at the radio configuration for 6 gigahertz, you can see that that access point is connected and the radio is enabled. So I'm going to go to site WLANs because I need to set up a Wi-Fi network. So I'm going to say add new WLAN. So let's call this demo Wi-Fi 1. Have to put in a password here. Now for security, I could use WPA3 or WPA2. I could use 802.1x. In this example, I'll just use PSK. Many options available here, including setting the VLAN as untagged or tagged, etc. But I simply want to get a basic Wi-Fi network set up, so I'll click Create. And then on my phone, let's have a look at the Wi-Fi networks. So I'll go to Settings, Connections, Wi-Fi, and we can see that network, Demo Wi-Fi 1. I'll put in my password, press Connect, and notice I'm connected to the Wi-Fi network. So on my browser, I'll go to Juniper Networks, and notice right on the home page, it tells us about the HPE Juniper acquisition, and it also talks about the AI native Now event series. And notice who's right on the front page, one of the founders of Mist AI. Now going to clients, Wi-Fi clients, I can see the device name, IP address, MAC address, can see the SSID being used. If I click on the device, I can see receive physical rate, transmit physical rate, can see information about data that's been sent, whole bunch of information just available with this very basic setup. But I could also go to Client Insights and then I can see a lot more information. So I'll zoom in a bit here. We can see DNS was successful, Gateway ARP was successful, DHCP was successful, authorization and association was successful. We can see the VLAN the client belongs to. We can see the DNS server. And I'll just zoom out there. Notice DNS server 192.168.0.1. We can see the band that the phone is connected via. So 2.4 gigahertz, which channel it's using. So just with this very basic setup, I can see Wi-Fi information, network information. I can also see where the device went. So went to Netflix. And that's because on this phone, I've been doing a speed test by going to fast.com. Now, the network that I'm using here isn't very fast. It's only, you can see it's about 80 megabits per second. That's got nothing to do with the Mist configuration. That's got to do with the physical network here. But notice I can see all that information directly through the portal. So going to Marvis actions at the moment, no actions are shown. There's no bad cables as an example. There are no issues with the network. But this was a very basic setup. Let's make it more interesting and let's introduce some troubleshooting. Now, in a lot of demonstrations, it looks really easy to get devices registered and everything works perfectly. That may not be the case when you're setting this up. So let's troubleshoot some issues that you may encounter. Some of these issues we actually encountered ourselves. So this first example is a real-world example that we had when we initially set this up. David, who's on my team and based in South Africa, was having problems where some devices couldn't see the Wi-Fi network. So he configured the access points, he configured the Wi-Fi networks, but nothing seemed to be working. His clients couldn't see the Wi-Fi network. Now, this is what I really like about the Juniper Mist system. It's a central portal that allows you to manage many, many sites. You don't have to be local to help troubleshoot an issue or sort out an issue. So in my example, I've got 2 Juniper access points set up. Everything looks good here, both showing green, but are they actually working in the way that we think they are working? So under access points, you can immediately see that there's a problem. We're told, warning, 2 access points have reduced functionality. If I look at the second access point and scroll down, we're told immediately that there's a problem with power. And notice here, power source is 802.3 AF. Only 2.4 gigahertz is available here using 1x1. That's a really poor usage of a very powerful access point. Notice we're told disable 5 gigahertz and 6 gigahertz. So in the practical demonstration that David was setting up, what happened was only 5 gigahertz was available, not 2.4 gigahertz. So no 2.4 gigahertz clients could see the Wi-Fi network because it had been disabled because there isn't enough power. Looking at his specific access point, notice here, this access point AP34 requires 802.3 AT power for full functionality. You can use 802.3AF power to connect to the Mist cloud, but you'll see a warning message saying that the power is insufficient. In my example, using the AP45s, which I have 2 of here once again, this also requires 802.3 BT for full functionality. Really important that you check the power that the access points are receiving. On the Juniper website, we're told that PoE was first defined in IEEE 802.3AF, which supplied up to 15 watts of power to a connected power device. So that's the power at the switch or PoE injector. Now, Juniper have done extensions to that, but IEEE 802.3AT or PoE Plus supplies up to 30 watts of power. And then there's a Juniper extension supplying power up to 90 watts. But again, the standard 802.3 BT or PoE BT supplies up to 90 watts of power. So on Wikipedia, as an example, we can see power delivered by the PSE or power available at the powered device or PNE. So 802.3AF, 15.4 watts, 802.3AT or PoE Plus, 30 watts. And then notice 802.3 BT type 3 is 60 watts. And then 802.3 BT type 4, PoE plus plus, is 90 watts. So you need to be careful. These two are shown as PoE plus plus, but we've got 60 watts and 90 watts. So going back to the Juniper system, on the other access point, so access point 1, what's nice here is we can actually see the device that's providing the power. So USW Lite 16 PoE, little switch at the top here. We can also see that there's a degradation in performance because this is only providing power at 802.3AT levels. So we do get 2.4 gigahertz, 5 gigahertz, and 6 gigahertz, which is much better than the Cisco example, which is only providing 802.3AF levels of power. So in this example, again, we only get 2.4 gigahertz, or like in another example, we only get 5 gigahertz. There's not enough power to power all the antennas. So we're only getting 1 by 1 as an example, and we can't use all the bands. So very, very quickly, we were able to troubleshoot an issue with the network not performing as it should. So either not all antennas are being powered. Again, fantastic access points, but if you don't give them enough power, they're not going to operate as well as they should.
He's telling the truth.
Okay, so let's try a power injector and look at some issues with power injectors. So I'll disconnect the access point from the Cisco switch and plug it into this Unify power injector. A little power injector like this is not going to work very well because there's not enough power, once again, just like an older switch like this. I'm not using this switch at the moment. This Unify switch provides the full amount of power required, but I wanted to show you some issues using different types of devices with the Juniper system. Okay, so access point is now connected to the Mist system. Let's have a look at access point 2, still complaining about power issues. So scrolling down, we can see that it's now showing that it's actually connected to the USW switch, not actually connected directly. It's connected via this black cable to the Unify switch, but it's actually using power injector here. And we've actually made things worse because this is now PoE 802.3AF and only 2.4 gigahertz is now available, whereas before we were getting more power. So if we look at access point 1, notice it's getting 802.3AT connected directly to the Unify switch. So be careful with your power. I think that's enough talking about power. We can also see here that some of the access points are not using the order upgrade version. So access point 2 needs to be upgraded. So going back here, we can see expected version is this one ending in 139. So if I click on that, go to utilities, upgrade firmware.
How about an upgrade?
Proceed. I'm going to select that version and click Start Upgrade. And you can see the access point is being upgraded. Again, very nice interface here showing you what's happening in the network. Let's have a look at some more basic troubleshooting issues. It's difficult to simulate troubleshooting in a small environment like this. So in a moment, I'll jump into a demo environment that Juniper has that gives you a much better topology than just say 2 access points like I've got here. Now, obviously, this is not a very good way to position your access points right next to each other. That's obviously only because of the video here. But as you can see here, upgrading is almost at 100%. Okay, so there you go. Version compliance is 100%. We can see at the top here, we've got 2 access points, 2 AP45s. Connection status is 100%, VLANs 100%, version compliance is 100%. But let's see what happens if we unplug this cable. So the access point is still powered by the power injector, but I've disconnected the power injector connection to the Unify switch. So what we should notice is one of the access points is disconnected. Okay, refreshing the portal, notice we can see no Ethernet link. Has no link seen using power injectors but not connected to switch. Okay, that's really impressive that I was able to work that out. If I click on no Ethernet link, we told the AP status and we can look at the LEDs here to see what's going on. So notice there, it blinked twice. So amber or yellow if you prefer. That tells us here no Ethernet link. Has no link. Seen using power injectors but not connected to a switch. Now, many LEDs are shown here telling you what's going on. So as an example, insufficient PoE. Blue tells us that at least one wireless client is connected. So as an example, notice this client has just connected to this access point, so now it's showing blue. So very nice that we've got RGB access points here showing us the status of what's happening. So a whole bunch of options available here. If I connect that cable in, and I'm not using a very good cable here, but I just wanted to see what it would do with a not so great cable. Notice now it's connected back. So hopefully after a while, this will sort itself out and connect back to the Juniper Mist system. Okay, we can see that this has now gone green. So no client connected to this access point, but there is at least one client connected to this access point. And there you go. Notice it now showing connected. So both access points are connected. We've now got 100% connection status. So it's very nice to see how the Juniper Mist system makes it easy to troubleshoot Wi-Fi issues. Okay, but let's look at authentication problems. If I go to monitor service levels and scroll down, notice side events here. This access point was unable to reach the Mist cloud. We saw rebooting happening, saw some issues. Here we can see a Pixel phone connected to the network. So there was DNS success, ARP success, DHCP success, authorization and association success. But notice previously we had an issue with that phone and this Pixel 8 phone. So if I zoom out a little bit here, Pixel 8 Pro connected to AP45.1 using this Wi-Fi network. So demo Wi-Fi 2.4 gigahertz WPA2 using 802.11ax was having an issue, and we told right away what the problem is. Previous authentication no longer valid. So there's a PSK mismatch. So authentication type is PSK. And what I really like here is I can download a Wireshark capture, so PCAP file, and open that up and see what's going on. So a client device was having a problem connecting to the network. What's fantastic here is at the time the problem happened, we got a log of what the issue is and a Wireshark capture. Rather than trying to ask the user what was going on, we have data telling us what the problem was at that time. So again, really, really cool that you can do this. We can see here that the client tried to connect to the Mist system. So we've got an authentication message. Here, the Mist system is sending an authentication message back to the client. We've got the client trying to associate. There's a response from the Mist AP. And notice here, the Mist AP is initiating the WPA four-way handshake. So we've got message 1 of 4. Client is responding, so message 2 of 4. And then it just seems to continue doing that. We've got message 1 of 4, 2 of 4, etc. And then we've got a deauthentication message from the Mist system, and the client is deassociated. And you can dig into the details here of what's going on. The access point is challenging the client authentication message. The client is sending back WPA2 authentication. So notice here we can see the data, the actual WPA key, and then the client authentication fails. So what I really like about this is the access point is capturing this traffic. This is not from the client's point of view. This is from the access point's point of view. The capture is done at the time when there was a problem, which if you've been involved in troubleshooting, is really hard to troubleshoot transient issues, try and replicate them, or try and get proper information out of a user who's not technical, as an example. So at the time when there was a problem, PCAP was captured. I can open that in Wireshark. I don't have to rely on a user trying to explain to me what the problem is. I can see what happened at the time when it happened, rather than trying to wait for it to happen again and then be online when it actually takes place. This is obviously a very simple example, but hopefully shows you the power of the system. Notice here we've got an SAE authentication failure. So this is WPA version 3 rather than version 2. So SAE is being used here. If I download that PCAP file, notice here we see authentication issues between the access point and the client. Obviously very different to WPA2. We don't see the four-way handshake like we saw in WPA2. But again, we're told through a summary here that there's an SAE authentication failure. So there's probably a misconfigured password. And if we go to our wireless LANs, go and look at that WPA3 network as an example, we'll be able to see personal SAE configuration here and be able to look at the password. So I won't reveal the password here, but if you click on reveal, it'll show you the password that's being used, in this case PSK rather than 802.1ax radius servers. So enterprise authentication is just a simple PSK, but I could see the password and then make sure that the client is using the correct password for this Wi-Fi network. Now that's one way to troubleshoot, but a lot of us these days are interacting with AI. And one of the big selling points of Juniper Mist is Marvis. So I'll click on the AI icon here. So this is Marvis, and it says, "Hello, David, I'm Marvis, your virtual network assistant. Here are some options to get started." But what I'll simply prompt this is which Wi-Fi clients are having issues. And we can see here straight away that this Galaxy S22 Ultra is having a problem. So I clicked on it, and by doing that, it says troubleshoot the issue. And we're told immediately there is an issue with an incorrect password. We're told that the client is failing 100% of the time on this Wi-Fi network. This is only impacting a small number of clients. I mean, this is a very small network. We could look at the failure timeline as an example, and notice we can see here successful connects, authorization issues, and we can look through a timeline to find out when the problems took place. We can see a correlation. So the problem is on this access point. This is the Wi-Fi network causing the problem. And in summary, once again, 100% of attempts failed. We could also look at the scope of the impact, and we can see once again that it's only affecting this network. And if we look at client insights, we can see authorization failure, de-authentication from the access point, authorization failure, de-authentication from the access point. So again, this is a very small network. My Brave browser that I'm using here has inverted some of the colors, so that's why we're not seeing all the prettiness that you would see if you weren't using Brave like I am here. I'm forcing everything to run in dark mode, so the graphs would be prettier in your example than what I'm seeing here. But notice how easy it was to interact with the AI and troubleshoot a Wi-Fi issue. So using light mode as an example, I go to Marvis, let's troubleshoot. What do we want to troubleshoot? Let's say a device. Can you tell me something about the device? So rather than trying to find out the MAC address, I'm just going to say Samsung phone. And notice it's told me that it's found this device here and this device here. So if I click on the first one, I can see client insights for that device. So again, we can see the SAE authentication failures. We can download the packet captures. But if I go to monitor service levels and scroll down, notice I'll be able to see, as an example, the access points. I'll be able to see how long they've been online. I'll be able to see where they connected in the network. And I can see, as an example, the wired switch being used is a Wi-Fi switch. It's nice to have access points like these, but you don't need them to test the Mist AI system. Juniper have created this Mist AI test drive platform that you can use, where you can experience the AI native networking difference yourself. Use my link below to sign up. You need to fill in some of your details, and then you get access to a live demo. This is a lot more real world than me just having 2 access points. Under Marvis actions, we can see that there are 114 actions. This is the place that you would start your troubleshooting each day. So as an example, we can see that there's a layer 1 problem in this network. There's a bad cable, and we're told exactly where the problem is. Port gigabit 1019 on the corporate switch 1 has a bad cable. Notice the recommended action. These devices have a bad cable connected to 1 or more ports. For Mist APs and switches, test and replace the cable. For WAN edges, look at the documentation, and they give us a link to documentation to help troubleshoot bad cables. So this really makes troubleshooting a lot easier rather than running around trying to find issues in a network. Notice we see two other actions here. Persistently failing clients. Scrolling down, we can see 802.1x auth failure. We can click View More to see more information. So this unknown client is persistently failing authentication. That may be a problem with someone trying to attack your network or some other related issue. Let's look at connectivity issues. Authentication failures. Scrolling down, we can see various authentication failures. So as an example, on the corporate Wi-Fi network, we can see a nice graph of failures on the network. We can see that a majority of failures are due to specifically IEEE 802.1x authentication failures. Clicking on AP, we can see affected access points. Now, as the joke goes, it's always DNS. So under Actions Connectivity, we can see DNS failures. Scrolling down, we can see problems with a specific DNS server. So there are failing DNS queries here, affecting various Wi-Fi networks. So as an example, all WLANs are failing. Now let's look at APs. So we can see which APs are offline in an environment. So various access points are offline. So under Actions, let's go to Access Points and look at coverage holes. We can see that the following access points noticed frequent coverage issues around them. Please reposition or add more access points in order to provide adequate coverage. Very nice that it shows this. So this is the site. This is the access point. It affects the 5 gigahertz network. And clicking more, we can actually see where the problem is on our map. So on our map, we can see exactly areas that don't have enough access points, or the access points are incorrectly positioned. Let's look at insufficient capacity. The following access points have reduced capacity. Please check corresponding reasons to improve the capacity. So we can click on capacity. Looks like there's a problem with a third-party switch in this network. You're looking at switches. Issues that a lot of us may encounter and struggle to troubleshoot. Missing VLANs. VLANs are missing on these devices. So 2 access points missing VLANs. And we're told exactly which access points are affected, so access point and switch, and which VLANs are missing on a specific port. So on this port, VLANs are missing, and on this third-party switch, VLANs are missing. Very difficult to troubleshoot that sometimes. On this access point, VLAN 2 is missing. What about a negotiation mismatch? Loop detected. So spanning tree may not be configured correctly. On the WAN, we might have a bad WAN uplink. So on this site in Seattle, there's a ISP DHCP failure. On this site in Salt Lake City, there is a poor LTE signal strength. So we can see latency and jitter aren't great. So we can see here as an example that there's a poor signal strength observed for 80% of the time between those two dates. 65% latency, 35% jitter on that link. So other options include troubleshooting clients, data center applications, security, and so forth. What's really nice is if you start your day, hopefully there'll be no actions here, which means that the network is good. But if there are actions, if there are problems, you are notified about those problems and you are told where the problems are in the network. One of the hardest things to do with troubleshooting is to find where the problem actually is, what is actually causing the problem. And once you find it, then oftentimes it's quite easy to resolve. But trying to nail down the problem takes a lot of time and generally a lot of experience. This makes the process so much easier and is a great example of actually using artificial intelligence to do something useful to help network engineers better manage and troubleshoot networks. Notice AI is validating issues, VPN path down at Salt Lake City. So on the right-hand side, we see messages validated by the AI to help us better troubleshoot the network. So here we've got missing VLAN. Here we've got authentication failure, and you can change the actions to either show today or yesterday or the last 7 days as an example. So as previously demonstrated, you could use Marvis and troubleshoot network issues or use Chat GPT type questions to ask about problems in the network to help you troubleshoot. But these Marvis actions make it very, very simple to find problems in the network. Okay, big shout out to Juniper once again for sponsoring this video and sending me some access points to test. Hopefully you enjoyed this video and learned something. Please let me know if you have any questions. What's your experience of the Juniper Mist system? How do you think it compares to, say, other vendors out there? Please put your comments below. I'm David Bombal, and I want to wish you all the very best.